Howdy, so this is the very last video that we've got for my master's project. It's going to hopefully explore all the stages of production and the things that I did through this master's project. There's a lot in this, so it's going to go for quite a while. Apologies for that. But just to give a bit of introduction, so the previous master's project, I was left with a control rig that really couldn't be carried with the camera. So it was this one here. When we tried to put a camera on top of this, it just wouldn't support, just because it was made a little bit flimsy, right? So held together with some sticky tape and some elastic bands and things like that. So it just wasn't that great, but it did work. It did drive the camera, and it did drive Unreal Engine cameras as well. So adding to that, we also had a light panel that did work. Once again, was manufactured in a slightly kind of raw way is probably the best way to put it. So that worked, and once again that really couldn't be mounted to the camera or anything like that. So we were left with a light panel that worked on a DMX-like framework. So what I mean by that is it worked exactly the same way that DMX works inside of Unreal Engine. But I was doing a manual kind of filter sort application and that type of thing. So there were a few positives inside of this project, or the projects in the past. Negotiated project 1 and 2, where the controllers worked quite well. We drove the camera, worked in Unreal, and the electronics of the lights also worked as well. However, there were some issues to do with calibration of the lenses, calibration of the light, calibration of the environment, and some synchronous issues with that as well. So overall it was working, however there was a lot more work to be done. So this master's project kind of takes on board all of those experiences that we had and tries to extend beyond. We've tried to develop it further, make it more usable, make it more user-friendly, make it more precise, and get all those calibration things working so we could actually have a product that works in the real world. So we identified a few areas of improvement. So the first one was the form factor of the camera rig. This two-handle thing could not support the weight, and we wanted to put a Blackmagic camera on there, we wanted to put some lights on there, we wanted to put a tracker on there as well. Without resolving this issue, we couldn't test to see if the whole kind of thing worked in conjunction with each other. So there was a little bit of re-engineering of the controls that needed to happen. There were some issues with the reliability of the electronics as well. Some of the sensors would fluctuate wildly. Sometimes it would just kind of disable itself just because some of the soldering work was not that good. So some wires could easily pull out and things like that. So we wanted to revisit the actual manufacturing process of the electronics as well. I did want to use the full DMX protocol inside of the whole virtual production process. At the moment I've kind of cobbled together my own interpretation of DMX, where the code manually split up the string, allocated it to RGB, and drove the lights itself, right? So there was a bit of work to be done in that, just to explore proper DMX and how that works. And then adding to that, there was a bit of a need to properly calibrate the camera, properly calibrate the color, calibrate the lenses, so it actually would work in production. Because one of the biggest outcomes of the previous project was the light did work, however there was a lot of post-production that needed to happen inside of the presentation of it. So I wanted to try and eliminate that post-production, get that working as a seamless thing, and make it as user-friendly as we could. So this project is quite massive. It's the biggest one I've ever done. Draws on a lot of previous experience and new gain knowledge. But we're going to break this video down into 4 sections. The first one is manufacturing. We're going to go into a little bit of calibration. Then we're going to go into positional alignment and footage syncing, because we didn't do that either in the previous one because we didn't have the right equipment. And then lastly, a little bit of light matching and testing of the controls, just to make sure that everything works seamlessly. So we'll leave that there as the introduction, and let's get into the manufacturing of the device. So with the manufacturing, the objectives were to create a form factor that would easily carry a Blackmagic camera, a tracker, and potentially some two mounted lights that would essentially drive the whole kind of system, right? The current format, as I mentioned, was good for a prototype. However, it just was not good with holding significant weight. While the rods are pretty good in their own right, there'll be undue stress on some of this and some of these kind of joints and things like that, right? So in its current form factor, it worked with carrying a tracker but not a camera. So one of the first things I had to do was resolve this issue. How do we make it so we can actually test the project to see if it's actually going to work? So there's a few options here. One, we could try and think about ways we can adapt these kind of control sticks that are already designed to existing camera systems, or we can try and create one from scratch. And there's pros and cons of each, right? So one of the pros with adapting the controllers with an existing camera system is that everything else will work quite well. The problem is, will this be strong enough to be integrated into the system, and can we use any mount points on the actual system to do this? And one of the things I was toying about is using things like ARRI rosette kind of mounts and things like that, and I didn't know how to get my hands on those and adapt them. So one of the other options I was looking at was essentially creating my whole rig from scratch. So this one is completely made from scratch. Why can't I do the same with another existing rig? So I went to Thingiverse. I've seen them before that you can get full-on shoulder rigs, and I went to Thingiverse and I found a really cool one that seemed to be highly recommended, free, available, and I thought, great. There's a few challenges here. One was adapting the controller, but this will give me a good base to start off with. So part of the biggest challenges was trying to make the form factor work. So if I hold this, I don't have too much issue with holding control of this. However, where's the camera going to sit vertically? Is it going to sit here? Is it going to sit on the shoulder or whatever? How are we going to mount it? And I looked at things like shoulder rigs. And shoulder rigs are pretty good because there's a lot of weight support on the shoulder. It'll take a lot of weight away from the actual joints. And also they're quite easy to film with. And they're non-standard, well, they're standard as well for film. People are used to using these systems. So on the Thingiverse, the challenge is to say, take that rig and then take the control handles that we've already designed and replace them. So that connection point is critical. And I went through a few different versions of this. So you can see here is one. And essentially I thought, okay, well, let's create a collar. We can create a collar that'll fit around this point here, between the connectors, and then mount directly to an arm on the control rig and two holes to support it. That was evolved into something with 4 holes, right? Mainly because that was the prototype with 2 holes. With another one, there's a lot of kind of potential flex in this, right? Even me wiggling that around, it moves a bit. So, you know, the theory of more holes is better. It's already got one for the other end where it mounts to the actual camera rig. Can I duplicate that over there and then connect it up? So we went with that. We designed a collar for that, which does mount effectively to the other side, and that's designed to kind of increase stability of the camera rig. And there's a whole bunch of these different parts all over. So for example, we've got the shoulder mount version 2 with different holes, the actual camera mount, another one with thicker barriers which has been cut, and also some other custom bits like a cap for the end of the controller, right? You'll see there's a video being shown now of the manufacturing process. There was a lot of 3D printing and also a lot of 3D printing fails. You can see there's one on the right side of this footage right now. Really frustrating, but it did give me that flexibility of designing and modifying the existing designs to get exactly what I wanted out of the design, right? So through that whole process, I printed that Thingiverse thing, made a lot of extensive modifications. Some of the modifications I did was literally changing the diameter of the holes that mount the rails. I didn't have 15mm rails that are standard for film. I had 16mm, which was leftovers from I think it was like a clothes rack or something like that. So I was kind of just modifying the existing Thingiverse thing to fit with 16mm rails. Changing it so it would handle the type of camera tripod mount things that I've got, making sure that it's stable enough so the camera didn't slide around a lot, and went through a lot of manufacturing kind of stages of this just to fit that Blackmagic camera on securely, safely, and also adapt to my own controllers. The controllers also went through a lot of changes as well. So one of the things that I was very aware of is that the existing controller was held together with tape. It was held together with elastic bands, and the screw holes were constantly stripping. I used small collars, it's hard to see on this, but little kind of nuts that were threaded that you could put inside of the 3D prints to secure the whole thing. So my objectives not just to adapt a control mount to this thing, but also to strengthen the whole build quality. And we got something like this out of it. It's a whole system that has been completely built from the ground up, all 3D printed, mounted together with proper bolts in there. And you'll also see, if I rotate it around, there's bolts on the inside of this, and it's all held. Unfortunately, you can also see in this shot, some of the parts didn't survive. And I'll go into that a little bit. There's a bit here as well. If I rotate it around, it's actually starting to crack. Quite difficult to see on the screen, but starting to crack. But the whole system, regardless of the couple of cracks here and there, actually worked quite well. You can see here, it's on the mount on the shoulder, quite secure. Camera fit there, and you'll see some video of this actually working as well, and it worked pretty good. There were some issues, as you can see, with this crack here. I'm going to show you a bit of a sneak peek of the testing process now, where the whole thing kind of failed. But we have to look at that, identify exactly why that failed. A lot of this comes down to material properties. Resin is notorious for being a little bit brittle, so therefore when I was putting it under some rigorous testing and strain and stuff, just didn't really cope with it. And there are other things on here as well that broke. So here's another one. This broke in the testing process, and it's just the shoulder mount adapter. Too thin, too much strain, and it snapped pretty clean off. So most of this can be resolved. The current setup was using this kind of water washable resin. There are other resins out there, such as this Soraya Tech Blue, which is sold to be a little bit stronger in material, a bit less brittle, more kind of industrial in sense. So I've yet to use this. I'm really excited to try this after this project is handed in, see if this will kind of fix some of those stress issues. That's it for the manufacturing process. There's a lot of things that went into consideration with this to do with the electronics. They've been completely redesigned from scratch. The existing camera rig was modified heavily to adapt the controllers. The controllers have been redesigned and re-engineered as well to fit to that rig, but also to be a little bit more secure. And it kind of did work, and it worked on an indie scale. There were a couple of failures to do with material types and properties that needs to be resolved. There's a lot more to explore with this, but that camera rig essentially did work. Some of these parts were added as well. This kind of shoulder offset was added for ergonomics. I've seen them before in existing camera rigs, but they weren't on the Thingiverse, so I've designed my own. and yeah, there's a lot to talk about in this section. The next section I'm going to talk about is actually the light panel manufacturing process. Essentially, I wanted to convert that big light panel to something that was more manageable, more portable, and more accessible. So that's next. So the next challenge was to take the existing light board, which we have here, and turn it into a form factor that we can create essentially like portability of the lights. Problem with this is you can't secure it to a camera mount because it's too big. Where does it sit? How do I carry it? It's just a bit cumbersome. So we wanted to go from something like this, which is very big, to something like this, which is more portable. And we also wanted to try and clean up some of the wires and the lines and make it a little bit safer for user testing. So we went through a lot of kind of re-engineering of this as well. So the essence of the lights are exactly the same. You know, they're just strips of RGB, addressable RGB lights stuck to a board that has been mounted and soldered together. So one of the things that I wanted to really do was clean it up, design a simple box. There's nothing really flashy about this. You can see on the back, this is what it looks like inside. There are two of these, which mean that they can be mounted both on the camera mount, right? But the electronics inside of it has been kind of changed and redone. One of the things I did find inside of this was a DMX kind of light panel from the SparkFun group, which is kind of pretty cool. Later found out that any ESP32 can run the DMX protocol, so we've got some other ones that we've used previously. But these panels have a denser LED pattern. You'll see that if you have a look at the original ones, they're quite spread out between them, and then these ones are much denser. And the objective was to try and get a little bit more light inside of a smaller area to see if we can have that handheld and can illuminate from different angles as well. The reason why the LED screens or the light stages work is because the light is surrounding the person, or the person in the foreground that's being filmed. So the objective was, if we can put a few sources of light around, more the better on the portability side of things, well then we can illuminate from different angles the environment inside of the game engine. So that was the objective. These were re-engineered. You'll see some videos on the screen right now of it being constructed. Bit of CAD work in there as well, and then engineered to be a small form factor. There were a few different processes used here. So these panels are printed with PLA plastic, which is different from the resin. You can hear it there, totally different. But this also produced its own little challenges. So the accuracy of the holes is not so accurate. I tried to use a few different techniques of melting in those little nuts that you could see before and pushing them into the plastic, which kind of worked in some areas and kind of didn't work in other areas. And then, yeah, just kind of, you can see that there, actually melted in. Right. There you go, you can see it there. But overall, these were quite simple to reproduce. There was nothing kind of overly complex with the engineering of this. They work quite well with the form factor that they're in, and we use some kind of mounting arms such as these to connect to the camera. Right, so that end goes to the camera, that end goes to the light, and then they can mount to the camera, and you'll see some shots of that as well right now. But overall, we ended up with 2 portable DMX lights right there, and then 1 original LED panel from the previous one, which we ended up using in the whole thing. The objective was to get all of these lights working simultaneously, all together on the DMX protocol, and we'll get there. But overall, that's the manufacturing process. In the total, we've manufactured 2 light panels from scratch, and we've also done the whole engineering of the camera rig from scratch, which is pretty cool as well. So once we'd finished with the engineering of this and we've done the manufacturing process, the whole point of that goes into using it in application. one of the first stages to getting this to work in application is the calibration process. We wanted to make sure that all the systems that we have, the camera controls, the rig, the input or the video input into engine from the camera, everything was synchronized from engine to physical space, and that required a fair bit of calibration and consideration of calibration, which I hadn't done much before, and I wanted to learn that. So that's going to be the next section, the calibration of the system. The calibration of the system was a crucial part in the whole project. If the system wasn't calibrated from the start, well, then we couldn't really prove that the lens controls were working adequately. We couldn't get the lighting to match up. There was so for example, in the previous project, there was some exposure issues with the light. And we also couldn't see if the camera rig would actually work effectively. So there was a big kind of process of calibration that went into this project. To start off with this, I thought, okay, well, the best way to approach this calibration is to make sure that the virtual environment matches the physical environment. And if they both match, well, then we can ensure that the exposure matches, the aperture matches, the lens distances match, and all that type of stuff matches. So we started off quite extensively on trying to create a rough digital replica of the physical environment, and I was using a augmented reality room to help me with this. It's green screen walls, and there's a decent computer in there as well, and it's kind of set up for this type of stuff, right? And it's controllable space. There's no changing lights. It's all exactly the same. So from that, I did a 360 panorama photo sequence of that, and that's in HDR, so we can increase the brightness and reduce it as well depending on how intense we want it. So that was done. I took measurements of all the room, so I measured the height, the width of the walls and where everything was, and then I created a rough digital block out of the room, and did a projection map from that spherical HDR panorama onto the walls to try and essentially create a textured version of the space. Now that had some issues. The photo stitching didn't quite work, and the geometry wasn't perfectly aligned, but the whole point of that was just really to get correct reflections in place and the environment roughly with the same lights in place as well. It wasn't critical that matched perfectly, because it's just a throwaway digital set essentially that was going to be used to simulate or try and match up the physical with the virtual. So from that, we took the rough images of the virtual set, and we placed lumen lights in there, and we measured the lux value of the lights in the actual space using my mobile and a bit of an app, and you'll see some screenshots of that on the screen right now, and then translated that over to the physical space or the virtual space to try and match them up one to one. The next stage was to look at the brightness and the exposure of things such as like digital replica of objects. We had a grey ball, we had a chrome ball in there as well, and we also had a color chart, and those were all to try and match the reflection values, match the grey values, and match the color values inside of Unreal. Everything was to try and, or the objective was to try and replicate the physical space, so it's one-to-one perfect. Then we've got tight control over the camera, the exposure, aperture, anything, the movement, the physical translation, all that type of stuff. This was kind of tough in everything, because any kind of minor offsets for measurements and things like that were replicated when I was trying to do the positional tracking. You'll see that in some of the videos coming up as well, but overall we created a rough virtual space that was adequate enough to do some testing. So there were some challenges to the calibration process. I had a set of lenses, and each lens had a completely different property, so we needed to go through and try and match up the focal length and the aperture on each lens independently. Now to do this, there was a point where I noticed that if I just kind of directly connected these values together, I noticed that the focus would come out of sync at certain points, which was quite frustrating. But when you actually think about a lens, the lens isn't a linear focus, so it will start off with, depending on the lens, it might be a focal distance of 30 centimeters, 50 centimeters, 70 centimeters, 1 meter, 1.2 meter, and then it'll go to 2 meters, and then it'll go to 4 meters, and then it'll go to infinity. So you think, obviously, if the potentiometer that you're turning starts off at 0 and ends at 4095, the value will be consistent depending on how far you turn the potentiometer. However, the range on the lens is from, I don't know, 0.3, which is 30 centimeters, to infinity, with the next stop being 4 meters. And if you think about that in terms of the same potentiometer value from 0 to 4095, as you reach the end, the distance becomes quite exponential higher away from the point. So that was the theory behind it. I did a few testing kind of videos and stuff, and I watched one of, I think it's Aidan Wilson's video, who goes through the process of calibration of lens, and I thought, okay, well, that's using it for a slightly different method than I am. However, the principle is exactly the same. So I went through and I mapped out these lenses and the distance and the potentiometer value over time. Well, not over time, over the potentiometer value. And we mapped out each of these points and plotted it to a curve. And you can see here are some screenshots of those curves. Those curves are exponential in nature. So it was quite clear that I needed to do that for every single lens I was using. One other thing that I did want to test out, I wanted to see if the aperture was exponential as well, because I don't know. I didn't want to kind of assume things or anything like that. So I went through and I mapped them all out. You can see here are the results. You can see it's pretty much linear from the lowest aperture value to the highest aperture value in connection to the potentiometer from 0 to 4095. So we left that as a linear kind of value, and we've mapped those. So from that, we've created a curve profile inside of Unreal Engine, and we've connected that to the lens focal distance. So when it's at a certain value on the potentiometer, that corresponds to the certain distance of focal length, or the focal distance, I should say. So that was a crucial part of calibrating of the lens focus. There are some issues to do with the potentiometer or the camera kind of drifting out of sequence. However, if you took it right back to 0 and then up to the maximum and then found the focal point slowly, you'd be fine with them matching pretty closely. So that was a pretty big breakthrough. The lens focus or focal distance was mapped, the aperture was mapped, and lens profiles were created for each of those. From that, we did that for probably 2 or 3 different lenses to create a few different profiles, and we tested those out, and those lens tests seemed to work quite well. You can see some on the video right now. From that, there's the next stage of, okay, well, we've got the lens working, we've got the exposure working quite well, we've matched the lights quite well. However, the video coming in and the color space of Unreal Engine was not matching. One of the things that we needed to do was we needed to calibrate the color as well, right? Because if the color doesn't match, then the actor looks fake and then everything's out of whack, right? We need a few things to work at the same time. So there's once again, Jake Water has done some stuff on color, and I had a look at some of his videos, and he has some really good stuff on OCIO profiles and color space transitions. And essentially what we needed to do is we need to look at the Blackmagic color profile. We need to figure out how we can get it into a format that can be converted once it gets into the engine, because the Blackmagic color profiles are a little bit non-standard. They're not like Sony's or Canon's, which have got kind of default standard color profiles or industry standard color profiles. So essentially the process went: capture some footage with a color chart, take it into DaVinci Resolve, use that color chart to derive a lookup table, take that lookup table, so we wanted to convert it from the Blackmagic standard to Rec 709, which is very common color space. Take that color profile that lookup table we created, upload that to the camera, make sure that the camera is outputting that Rec 709 directly from the camera, so we're overriding the Blackmagic color format, and then connect that into the camera via the deck link and the adapter. We can see that on the screen right now. These were two critical things that we were missing in the previous project. And then from there, this is quite a long process, but from that we wanted to convert the Rec 709 video into linear sRGB, which is essentially the color format that Unreal uses. So it's managing this color from the Blackmagic to a different format to another format to match it with Unreal Engine. And you can see as we go through that process, the color gets more accurate. Now there's a few things to note in this. I think the colors are still a tiny bit off, and that could be due to the fact that I captured the color chart inside of a green screen room, and it could be picking up some colors. It could also be that I made a bit of a mistake in maybe a couple of settings here or there, but overall the color coming in is quite desaturated and gray. On the end of this process, it's pretty close and in line with the virtual version of it, so there's some positives in that. So from that, we've done lens calibration, we've done aperture calibration, we've done color calibration. Some tests were done on positional tracking in the environment based on creating a virtual space using the HTC Vive tracker, and that's a little bit off still, however it doesn't really matter. At this point we can kind of push the DMX or the camera position and footage sync and a little bit of DMX stuff just to make sure that we've got the process fully kind of calibrated and good to go, and we can test the actual idea. Will this work? Can we use microcontrollers? Can we use a custom light system to create more accurate lighting and integration of virtual environments? So let's have a look at the camera calibration, positional stuff, and footage syncing. So there wasn't too much involved with the camera position and the footage syncing. We've done a few tests to do with the camera position in previous things. So we've used the HTC Vive tracker and the controller, the custom controller, to essentially create virtual cameras that can be controlled in the physical space. This area that we lacked from the previous assignment in the negotiated project 2 was to do with the footage synchronization. We didn't have the capture card, we didn't have the capture box, we didn't have the cables associated with that as well. So we wanted to make sure that all of these things, which were kind of knowns anyway based on the research performed, would actually work in practice. So it was pretty straightforward. It was a live link for the HTC Vive tracker into Unreal Engine 4 to drive the camera position of the virtual camera. It was footage from the Blackmagic camera into the Unreal Engine via the deck link card and the SDI cable. And then another couple of things that needed to be done was we need to timecode synchronize. So if we're going to record on the camera and we're going to record on the engine, that the time codes would match perfectly. As a result, we can, if we want to do some post-processing in another program like After Effects or Nuke or something like that, or even DaVinci Resolve or After Effects or Premiere, using the same timecode to synchronize all the footage, so it's one on top. And adding to that, we wanted to look into creating a gen lock. So essentially the objective of the gen lock is to match the frame rate from the camera to the frame rate of the engine. If there's slipping of those, well then the synchronization is not going to work correctly, and nothing would work in terms of synchronizing of the two. The timecode and the gen lock were done pretty easily using, once again, Jake Water, who's done some amazing stuff with this with the indie production field guide. He goes through a lot of this process and explains how he's done it, and that was done through custom timecode nodes and gen lock nodes, which were associated with the Blackmagic, which is pretty easy. There were some issues that were present in the whole thing. So, for example, rolling shutter is a thing on the Blackmagic camera 6K. So what that is if you move the camera left and right quite quickly, the footage will kind of shear. It'll shear in a direction because the shutter rolls like this as it captures the footage. So that was being shown inside of the footage coming in. However, the engine itself wasn't replicating that, which was a bit of a problem. You'll also note that some of the footage coming in was offset by a couple of frames, right? And that doesn't seem like much in the scheme of things, but it can make a big difference. There is nothing stopping you from recording the two and then offsetting one, just a couple of frames, just to kind of bring it in line if you're doing two different cuts and takes, right? We looked into composure as a means of compositing inside of Unreal Engine. Very much scratched the surface of the system. We've used the backplate. We've done a chroma key on the footage, quite poorly in a way, because the chroma key requires a very flat, evenly lit wall. We didn't really have that in the studio. We've done some choke matting on that. We've created an alpha channel from 3D objects, and then essentially done like an A/B kind of cutout or merge. So played around with some of that, and it works okay from what we were talking about. It's a good preview of what we've kind of set up. And if the keying was better and the kind of footage coming in was nicer without the kind of shearing of the rolling shutter, well then maybe we could have a pretty good user result. Unfortunately, I didn't do the whole gamut of testing in the space that I created because the controller itself broke. And if that didn't break, we probably could have had more rigorous testing to make sure that these were all perfectly ticked off and aligned. There are some potential issues with this approach of using the camera footage with the composure framework and the keying inside of the engine. If I used lights that were green, I could key out some of the actors. Wouldn't be able to easily rotoscope that out inside of engine. Maybe some of this stuff is better suited to a post-production workflow. So a previs inside of Composure to see roughly what it'll look like, but recording on the camera, recording of the take recorder inside of Unreal, rendering of the two pieces of footage together, and splicing it together inside of an editing package would probably be the best approach to doing something like this. But overall, we managed to get rough of the footage coming in, working okay, synchronized, and we're good to go. Some of the later testing didn't actually use some of this footage synchronized in Engine, just because we broke the form factor and had to test in a different environment. So that's mainly where we didn't have trackers and HTC Vives and all that. But that worked okay, and that's the camera position and the footage sync. The previous project lights worked pretty well to illuminate the source and match that with the virtual environment. However, that was only one light, and I was using my own kind of homebrew version of the DMX protocol. I wanted to see if the actual DMX protocol would work with more than one light, and if I could do that via Wi-Fi, that would be even better. The reason I started trying to chase the Wi-Fi was this SparkFun DMX thing plus thing. I saw a video on it and I was like, wow, okay, well this allows us to use the DMX protocol over Wi-Fi, which is really cool. And if I can use Wi-Fi and different channels, well then perhaps I could get them all working simultaneously, and we can add a few different lights. One light just wouldn't cut it, because if it was just one light, it would just be illuminating one surface area of the actor, and that couldn't accurately represent the left, the right, the top, the bottom, yada yada yada. So I wanted to see what we could do with creating a few different light panels and seeing if we could create immersive lighting from multiple light panels on an actor. So the testing approach focused on essentially trying to match the physical lights in one space with the virtual lights in the other space, and then checking to see if those lights would synchronize up and it looked similar. That involved using the tracking as well from the HTC Vive tracker, and the camera and the calibration and everything up until that point in the physical space. Now, in that testing process of doing my first pass of the DMX system with my 3 light panels, this happened. Let's put this on. No. Let's put this on. No. Now that wasn't really good because my whole kind of rig broke. We've got some issues to do with the handles breaking, nearly dropping the camera, the lights falling off as well. That was caused by the light panels being a little bit too heavy for the rig itself, and the rig not being strong enough in its own right. So the testing process in the actual testing stage that I set up wasn't fulfilled because I couldn't reliably carry around the rig, get the controls working, and use the lights, which was really disappointing. But we went through and we did another test at home on a green screen, this time without the moving camera, and this is what it looked like. Now you can see with this we have lights, 2 lights set up, which kind of worked but wasn't completely accurate. We also tried a 3 light setup with the bigger light panel, this one here, to essentially create like a rim light effect, a 3-point lighting setup, one here and one over the top. And that worked pretty well, I would say. The lights seemed to be matching roughly. The light values looked pretty good. It looked like it was reacting to space. So the reason I wanted to try this approach was because if I've got a light panel that's controllable in my virtual production stage, you can put your actor on the green screen in the certain position that you want them to, and then let the lights stay where they are if you have a nice little array of them, and then you can move around, you can film, you can use the joysticks on the handles, you can fly through the space in the virtual space and let the lights just react to the environment that's in the virtual space. So the cool thing is the 3 lights worked all in the same way. I did have to use a custom Wi-Fi network. So this Wi-Fi network allowed me to essentially eliminate any noise. It was isolated in this Wi-Fi network, so therefore it was all kind of safe and secure and easily sending out to the address. This is scalable up to potentially 20 lights. I think that's the universes on the DMX protocol. So you can have them really kind of scattered everywhere. Right. There are some potential issues with the lights if the light panels start outputting excessive green panels and you're chroma keying out, and that could be issues. But that's something that can kind of come to that when we get there, right? So the result of this kind of testing process of the DMX lights was that the lights are pretty effective at illuminating an actor, and that will kind of match the actual virtual space pretty well. But that's not surprising because that's kind of what a light stage does. It illuminates the actors from multiple angles with multiple colors from the virtual space. The good thing is that these light panels can be manufactured for around 40 to 50 pounds, and you can get some good results from that. So overall, some kind of positive outcomes from this testing process, even though the original testing process kind of failed abruptly. The subsequent testing that we did demonstrated that the actual concept does work, and works pretty good. So just to conclude this project, I think that the ESPs are an amazing thing. These little chips right here, these little chips can do so much when it comes to virtual production if we explore them further. They can help us facilitate communication with the camera, with Unreal Engine, with LED panels, and anything else that we really want to do, which is kind of cool. It's actually really cool that these little chips that are super cheap, you can get 3 for, I don't know, like 12 or 14 pounds, can do so much inside of the virtual production space. We have successfully developed a rig that is controlling virtual cameras and physical cameras. This rig is in a nice little form factor and it will work pretty well. And that rig has custom electronics, controls, works pretty well with controlling physical and virtual cameras. And yeah, there are some issues to do with that, which I'll address in a second, but yeah. We've also managed to use our own custom lighting panels, which are once again quite cheap to manufacture. Around £50 per light maximum. You could probably do it for cheaper if you use the right 3D printers and tools and stuff like that. And that works pretty well with replicating virtual environment lights in a physical space. I would imagine if we had a few more light panels in there, just spread out, almost in like an arc around the space, we might be able to replicate a virtual production stage on a small budget. Obviously, those more lights will be, better at illuminating the subject matter, and they can be controlled, right? So that's something that is scalable, pretty easy to produce, and works pretty good. Good thing about it is it's flexible. If you wanted a big light panel, you can make one. If you wanted a small light panel, you can make one. You can make it in any form factor that you want. If you wanted strips around an area, if you wanted like bands, you could do that. And it's all hookable up to DMX, and it can be addressable as well. And you can also play around with the intensity of those lights, changing the hardware attached to it. So there's lots of kind of dynamic things you can do with the light panels and the DMX protocol. The rig itself does need to be engineered a little bit better. So obviously we've designed the adaptation to it. I'm currently working on another version of this. You can see some of the kind of prototypes on the screen right now, but we're talking about the screwing things in rather than just kind of sticking them on. We're talking about making them out of one piece rather than multiple pieces. Anything that we can do to kind of increase the rigidity of what's being kind of put there, right? Just to give it a little more stability. The use of other types of resins to act with more strength. Gonna try that, see if that's gonna work a little bit better. Might also try PLA or ABS kind of printing as well. Haven't actually tried that, so that would be an interesting one to experiment with. So overall the design worked pretty good. The ergonomics of it was not too bad. It held the camera okay. Some improvements on the adaptation to where the lights can mount to, but overall it's pretty good. The LED panels can be addressed a little bit differently. They can be improved on to have things like batteries that are removable and chargeable. Right now we're using a USB to drive those, and if we have the right batteries we can increase the lumen output of those as well. And some kind of ease of use things such as on-off switches, toggle switches, stuff like that. On the software side of things, it would be good just to have a little bit more of a calibration process, so almost like a heads-up display or something that can go through the calibration steps of what lens are we using, what camera are we using, what's the settings in there, just to set it up and then press go. The current form factor of the project is pretty good. You can drag and drop a folder and hook up a couple of things and we're good to go. So in its current form, it's pretty usable. To roll it in from one project to another project is pretty good. However, there's some more kind of ease of use things that can be done to this. But the cool thing is, I think overall the project demonstrates that we can control a virtual camera with a physical camera sync. We can play around with lights and we can replicate lights on a very cheap factor. So this rig itself can be manufactured for a bottle of resin, some parts, some electronics and some cheap rods. The light panels can be done pretty cheaply as well. Those strips of LEDs are pretty cheap, and the chips themselves are pretty cheap. So I think there's a lot of promise inside of this project for indie developers, schools, for universities, anyone on a budget that wants to dabble with virtual production. The most expensive thing you're going to get in this situation is the camera and the capture cards. However, that's always going to be there for anything kind of CG related as a big issue. So overall, I'm pretty happy with the outcomes. This project was immense, so many different stages in it, so many moving parts. So I'm pretty happy with the outcome, and interestingly, I'd like to just continue working on this to push it further and make it as stable as possible. So look out for that. I'm sure that's coming in the future. So thanks for watching, and I'll see you later.